Given a linear function, we're going to graph by plotting points. Number one, we're going to choose a minimum of 2 input values. 2, evaluate the function at each input value. 3, use the resulting output values to identify coordinate pairs. Number 4, plot the coordinate pairs on a grid. And number 5, draw a line through the points. Example number 11, graphing by plotting points. We want to graph the function f of x, which is equal to negative 2/3 x plus 5 by plotting points. Step 1, we begin by choosing input values. This function includes a fraction with a denominator of 3. So since it has a denominator of 3, we're going to choose multiples of 3 as input values. So we can choose 0, 3, and 6. And what that will allow us to do is when we plug that value in, it's going to eliminate the denominator of 3. So we're going to evaluate each function at each input value and use the output value to identify coordinate pairs. So the first value that we're choosing is x is equal to 0. So we're finding f of 0 by plugging 0 into the function. So negative 2/3 times 0 plus 5 is 5. So therefore our ordered pair is going to be 0, 5. The next number we're plugging in 3. So f of 3 into the function negative 2/3 plus 5. Well, negative 2 over 3 times 3 is negative 2 plus 5 gives you positive 3. So that ordered pair is 3, 3. Next value, x is equal to 6. F of 6 is going to equal negative 2/3 times 6 plus 5. Well, 6 divided by 3 is 2, and 2 times negative 2 is negative 4, plus 5 gives you 1, and therefore our ordered pair is 6, 1. And now what we're going to do is we're going to plot those coordinate pairs and draw a line through the points, and figure 11 is going to represent the graph of that function. So we have the first point, which is 0, 5, the next point, which is 3, 3, and the last point is 6, 1, and then we connect the points, drawing arrows at the end of the line, indicating that it's continuous. Now, the graph of the function is a line as expected for a linear function. In addition, the graph has a downward slant, which indicates that it has a negative slope. This is also expected from the negative constant rate of change in the equation for the